Well, thank you very much for being here with us. It's the second time that we're on this track now working with EnBW, EnBW as well as Microservices working together on an energy-based system as far as I know with the utilities. I don't want to go into it any further. Just in order to give you some background information, Christina, Andreas, you are actually not.
Yes, he is the co-speaker from EnBW.
Yes.
Okay, so Andreas is the co-speaker from EnBW, and Christina is her bio is inside. She leads several EnergyBASE customer projects in the embedded area, and is also part of the advisory board of the ESE Congress that really focus on manifold different issues and challenges with respect to the development of device and management systems. So please welcome Christina and Andreas, and we all have fun.
Thank you very much.
Okay, thank you. Hello everybody, thank you for joining our call, Smart IoT Devices Enabling New Business Models for Utilities. I'm Andreas Gassmer, I'm technical lead of the project we do together with Microservices. And I'd first like to... Doesn't work? Oh, great. I'd just like to introduce EnBW for those of you who don't know us. We're one of the largest energy companies in Germany and Europe at all. We have business segments in sales, grid, renewable energies, as well as generation and trading. We have a revenue of in 2014 of more than 21 billion. We have some 5.5 million customers and some 20,000 employees. The thing in Germany we call Energiewende is a big challenge for a electricity company or a utility at all. Of course, this was the past. As you see on the left side, we produce energy on central points, and now the energy production goes distributed over the country. And actually we have, or in 2014, we have 1.5 million PV plants distributed our customers that now deliver energy in our grid, and in the past days they consume energy from our grid. What Energiewende means for a customer is that, as I told you, the customer consumes energy, gas and heat in the past from our company or for utilities, and nowadays they produce their own energy, and they not only produce their own energy, they also charge their electricity car, they do thermal heating, they do energy generation, they need to control their water pump, their heat pump. And this is a big challenge for the customer, which we think, and most of the customers also, is a customer not able to do because it's very complex, as you can see. Our product is called EnergyBASE, and this is a main control unit. Actually, it's a multi-phase meter that gets installed at the customer's customer, and it controls all the connected devices. For example, the inverters at the PV plant. It controls battery storage. It controls also connected home devices. But this is not our main focus. We also want to connect smart home systems. We have an open API that smart home systems can connect to. But what you can also see is there is a big challenge to connect all these devices, not via software layer, but the physical connection is also an issue. So we choose as backbone for our system DLAN, which is a protocol that goes over the wire, over the electricity wire, and over this protocol we connect our devices for smart home or for wall plugs where you can measure your energy and you can turn devices off and on. We use C-Wave because it's widely spread at the moment, and we also support different inverters and also different battery storage systems that you can connect to our EnergyBASE and that we control for you. The EnergyBASE itself is a SCADA system, as most of you know, because we control inverters, battery storage systems and stuff. but it also is responsible for security stuff because we can monitor the health state of devices. We can inform you if something goes wrong. We have all the data stored local on the EnergyBASE, which means that we do not push every single byte to the cloud. We do data processing on the EnergyBASE itself, and we just move data to the cloud if the customer agrees to that, and wants additional features we can only offer if the data goes to the cloud. What we also focus is energy efficiency, which means we do forecasts for generation, forecasts for consumption on the EnergyBASE for each household. And we do also optimization, which means there is a optimization algorithm that runs on base of the forecasts and optimizes the energy consumption. This means the optimizer can give you tips that you can do your wash machine on the next day, or your tumble dryer, or you can also connect wall plugs or devices that the optimizer controls by itself without any need to do something. And what we also did, and where OSGI comes into main focus, is that we do this on a service base. That means you have a base setup, which is a optimizer, a forecast, weather services, devices, but you can also book additional features, which is not only not available at the moment, but you can think of healthcare and stuff like that. Our architecture looks like this, which means the EnergyBASE is installed at the customer, and the customer can access the EnergyBASE via its web browser. A web server runs on the EnergyBASE that offers all the functionality to the customer, but it also connects to the backend if the customer wants that. And he can connect over EnergyBASE.enbw.com or via its Android or iOS apps. And we also are connected to third parties or to mail servers and push notifications and weather forecasts. We consume weather forecasts from WED. They gave us weather forecasts in a small resolution, and we adjust them to each power plant's production. And this is what we call learning, because we use this data only as base, and we adjust them to the customer's specific data. So now I hand over to Christine.
Okay, my name is Christine Mitterbauer. I work for Microdoc. Just a brief introduction. Microdoc is an independent software vendor located in Munich. We have also locations in Stuttgart and Berlin. We have over 15 years experience in embedded software projects, large customer projects in the embedded area. We have an international customer base and doing stuff in automatics, telematics, smart grid, smart metering, whatever you want. And what's very new for us since 2014, we are Oracle OJPI partner, meaning that we can port Oracle Java SE embedded 8 VM to every hardware you have when the standard Java VM from Oracle is not running there. And this is one of the main points why we are coming into this project, because we delivered Java, or we acted as Java technology partner for EnBW. And in addition, we brought in our experience with large Java OSGI customer projects, project management, quality assurance, and we brought in additional development resources. But let's go back to the project itself. Having a look on the hardware, the EnergyBASE is a 450 MHz ARM9 processor, have 128 MB RAM, 4 GB flash. There is a built-in Ethernet and serial interface there, and we have an integrated polyphase electric meter for measuring energy flows. On the software side, we have embedded Linux running. The embedded Linux is no standard Linux, not supported by the standard Oracle Java VM, and there was some work necessary to get the Java VM running, and this work was done by Microdoc and leads to the Microdoc Oracle Java SE Embedded 8 virtual machine running on that. As far as Andreas already said, the software itself, or the service itself, is apps-based model, service-based model on the one hand, and on the other hand, we have a lot of different product variants because of the different devices in the households, and OSGI is the perfect software solution for that, having this framework, and therefore our software architecture looks like that, having the embedded Linux, our VM, I already told you, and having an OSGI framework running. We choose the processed MBS Smart Home OSGI, and having additional features there like the processed Home Device Manager, HDM, which brings us a lot of functionality we can use out of the box. And which came with the SDK, so that we had the chance to implement own protocols and own device adapters, which are not there very easily. You see we have a lot of other software modules there, device control for observing the devices in the household, configuration. We have basic services like storage, time, contract management for the services, backend connection, and so on. Then our prognosis services, which we need for the optimization stuff, and UI REST app frameworks for having this layer above the apps layer for the end customer. But we will look deeper in that. This is the web UI a customer has, and he sees his different apps he booked, and here you see, for example, the weather app, a transparency app, the optimizing, and a news app. But now I want to have a deeper look in some technical details in such an IoT system. And I want to look onto the Z-Wave adapter. Z-Wave protocol layer, wireless protocol, Andreas already mentioned. And we faced a lot of issues with the Z-Wave implementation. The Z-Wave needs a lot of performance of our EnergyBASE, and yes, we need the EnergyBASE for our prognosis stuff, and we looked into it and brainstormed what we can do with this Z-Wave bundle residing here. And when we looked into it, we discovered that the Z-Wave controller we use, the Devolo PLC adapter, also has internally a built-in Java OSGI software stack running. And what we now did, we shifted the Z-Wave bundle as it is, little adjustments, you know, to the Devolo PLC adapter, who did relatively small work and had a lot of space on that. And so you see, having the same software stack on different devices is a very cool thing, because you can shift functionality like you want between different devices. And having a standardized framework like OSGI, you have the same APIs, and it doesn't matter if it's the same OSGI or if it's the same virtual machine on there. Okay, let us look on another issue we faced. Here you see the function as a picture for having the prognosis and optimization there. And I think it's no surprise for you, and as already mentioned it, we need weather data to have this photovoltaic prognosis. And we get the weather data from the Deutsche Wetterdienst, from the German weather department, but this is a relatively big data, data from all over Germany, and it's again no surprise that it's no good idea to put all the stuff on the EnergyBASE. And therefore, we used our backend. In the backend, we also have a processed implementation, the process backend server, the MPIM, which also runs in OSGI runtime, having the same stack Java OSGI, and having the ability to build up distributed OSGI services. And the weather forecast is connected to our weather backend bundle, which where each EnergyBASE client can demand its own pre-compiled weather data only for its location. And again, this was relatively easy to implement because of having the same software stack and also having the same system, the process system running on the EnergyBASE and the backend. Okay, I hand over to Andreas, who tells us our third decision we made within the software architecture.
Yeah, our decision was to build up apps, as we called it, which are actually microservices. We faced a use case and modeled it into a OSGI service. And this is pretty cool because all apps are implemented as OSGI service, and all OSGI services get transparently exported as REST service with JSON payload without the need for the developer to do anything special. It just has to specify I want to export this method or this interface, and everything is done. We just have a single interface, which is the REST interface. The apps use it, iOS and Android apps. The website itself uses this interface, and also our backend system uses the same interface. This API is open for third-party systems, and for example, if you think about the optimizer, you can not only turn on a wall plug, you can also submit an action URL where the optimizer can execute or triggers this, which could also be another REST service, and do functionalities, for example, on a smart home system. New functions are pretty easy to integrate because you just have to write a bundle with an export a service and you're done. And another feature that is also cool for us is that we can book services. So we can install a bundle on a specific device based on a customer contract and remove it if it's not longer valid for him. Our build system does also another fancy feature, which we think is pretty fancy because the backend system extracts the static content for the web applications, which is HTML, JavaScript, and images, and puts them on our backend system. And if the customer logs to the internet or via the internet to its EnergyBASE, then all the static content gets delivered by the backend system, and only the dynamic REST content or the API calls get forwarded to the EnergyBASE itself and deliver the actual data. And this is done using a TLS SSL tunnel that gets installed by the gateway and connects to the backend, so the customer has not to configure a kind of port forwarding or stuff like that. It goes just out of the box. With the backend, as Christina mentioned, we use the processed MPRM, which is a quite handy tool. We use it for device monitoring because it comes with a process monitor and stuff like that. We use the software repository where our continuous build system delivers software packages and also deploys it to our test gateways and to the customers. We use push notifications. We also implemented a bundle for the backend that does push notifications to Google and to iOS and email notifications. We implemented a geocoding stuff, the weather forecasts, and we also introduced some functionalities on the gateway itself that help support to discover what is going wrong, if something is going wrong on the EnergyBASE. One thing that we not mentioned already is that we not only have the OSGI Java stuff, we also have native stuff running on the EnergyBASE, which is actually the consumption forecast that is implemented by our math guys in R because they are handy with R and they don't know anything about Java. And we also have the optimizer running as native bundle. It's a MIP solver, and what we plan for future is that we move the solver and the R runtime into Java. We just had a look at Rengen, as some of you might know. Rengen is a R statistics library that runs directly on the JVM and executes the code on the Java JVM. And it's also in some points quite faster than the actual GNU R runtime. These are our plans, and this is also quite handy because if we do this or we have this available, then we can go one step further. If the customer or we want to offer additional functionalities that the EnergyBASE is not capable to handle, which means more advanced computations or stuff, then we can also shift this up to our backend system, and we can do the calculations there without the need to adjust or compile any native code and stuff like that. Yeah, that's it. If you have any questions, feel free to ask, and thank you.
The EnergyBASE looks to me a lot like a e-control white labeled extendable.
Yep.
More questions. How do you compare to KiwiGrid? Because they basically do the same. The hardware is a bit more like what I would imagine to have, because the e-control is a bit tiny for my personal taste,
I'm not the product owner of the thing. I think I can't answer this question.
You don't know KiwiGrid.
I know KiwiGrid, but I don't know what leads our product owner to stuff like that. I'm sorry.
Do you guys have integration with the EnBW KiwiCon smart home?
Not at the moment, because EnBW KiwiCon is actually a bit kept low, and actually we're just focused to get this up and running, and then on further steps we try to connect.
It's on the roadmap.
Yeah, but not for the next half year. Yeah.
Well then, me again. With regard to the rollout, did you have any first numbers on what? As far as I understand, this has been rolled out already.
No.
Correct?
We are just in the phase. We want to roll out until the end of the year. We have some customer-friendly installations, but the real rollout will start end of the year.
And then it'll go to all of your EnBW customers? Or?
No.
You have to buy this. It's a new product.
Okay. So it's just an additional offering to what you already offer?
Yep.
Okay, thank you. Any other questions? Yep.
How much of the stuff what you're using there is open source, and are you looking into open source implementations of protocols, stuff like that? Basically, what I don't know if you followed it. There was a discussion yesterday on the IoT unconference day about the protocol kernels and stuff like that.
Actually, we don't use. We nearly don't use any open source protocol, because a lot of protocols come with the processed MBS Smart Home, and with others, for example, with inverters like Costal, SMA and stuff, we have NDAs and we got the protocol from them. So at the moment we have I don't think we have any open source protocol.
I guess in the case of that way, that's almost impossible anyway.
Exactly.
Just a side question. You mentioned your own microdoc JVM or Java.
We are allowed to name the product coming from Oracle as when we ported it, that we can name it microdoc Oracle Java Embedded SE8.
So how's that different from? I think there's now think for the Raspberry Pi you can run, which has an ARM9 processor, right? So you can run a normal Java SE on there now. How is that different from?
It's not different at all. We run the TCK. You have a standardized virtual machine, but ported to your hardware if your hardware has some specific implementations which are not covered by the standard JVM. But on top of that, you have the normal Java 8 TCK virtual machine.
Any further questions? None? Then thank you very much.